Scientists can now edit human DNA almost like editing a document. Before we take a look at the newest technology available, let's take a look at the brief history of genome editing. So, the first publicly available genetically modified drug was insulin, which is now used by millions of people worldwide to treat type 1, type 2, and gestational diabetes. Additionally, the first genetically engineered vaccine was for the HBV or hepatitis B virus, which was licensed in 1981. Moving to the newest breakthroughs in genome editing technology, we have CRISPR-Cas9, that's CRISPR, which allows scientists to edit human DNA with high precision. Previously, genome editing that happened in laboratories required scientists to remove cells from the patient, edit the DNA within the laboratory, and then insert the cells back into the patient. But now researchers are moving to in vivo editing, which basically means the genes of the patient are edited within their body, which eliminates the need for laboratory manipulation. In fact, CRISPR-Cas9 has already been authorized for the treatment of various diseases like sickle cell disease, cancer treatment, and inherited blindness, and many more therapies are undergoing development and trials. Despite the massive contribution CRISPR is making towards improving human lives, it is not without its drawbacks. This is because CRISPR-Cas9 enables scientists to edit human DNA within the embryo, which raises ethical, legal, and societal concerns. In fact, one of the biggest controversies in genome editing occurred in 2018 when the Chinese scientist He Jiankui announced the birth of the first gene-edited baby girls, Lala and Nunu, who he claimed were resistant to the HIV virus. This sparked global controversy and then consequently led to his arrest and imprisonment for 3 years. However, the Chinese scientist's work is still a massive breakthrough in this technology. Other ethical concerns include designer babies, where we edit the DNA of the baby inside the embryo, changing or improving their appearance, physical health, strength, or intelligence. Additionally, there are two different types of genome editing, namely ungermline editing and germline editing. Germline editing basically means that the changes made to the DNA currently will affect all further generations, and this poses a huge risk because if any error occurs, this would be propagated to all further generations. Last but not least, it is a standard practice in performing medical procedures that we have to take the consent of the individual. But with genome editing, there is no way to obtain informed consent from the individual or the child that would be born. However, if CRISPR is used with the legal, ethical, and healthcare concerns in mind, it could, and in some ways it already is, changing and revolutionizing the way we see healthcare today. You see, the thing is, we're not just evolving anymore, we're starting to edit evolution. Let me know in the comments, would you use gene editing if it was safe?